Good day. For those of you who do not know us, we're the instructional staff for ECE 150, Professors Hiran Patel and Werner Dietl, and Douglas Harder. In this topic, we're going to discuss protecting pointers. So in this topic, we will learn how to protect the values associated with pointers using the const keyword. Now, you are already aware that a local variable may have its value changed by either assigning to it directly, or if you have a pointer that is storing that local variable's address, you can assign to that pointer dereferenced. So here, for example, x starts with the value 42 and star p sub x also has that value. However, if I assign 91 to what is at the address stored in p sub x, I also, of course, change x itself. So the output here is as expected. Initially, both are 42, and after assigning to what is at that address, both are equal to 91. Now, you also recall that we can declare a local variable to be const. That means we can initialize it, but we cannot change it. So here n is declared const and it is initialized with the value 91. If we now attempt to change the value of n, such as we do here where we use auto increment, we get a compile time error. The error is very specific. We are attempting to increment a read-only variable n. Read-only means essentially constant. We can access the value, but we cannot change that value. Now here we have a pointer. P sub x is storing the address of an integer. However, it's declared const. Now what does that mean? Does that mean that I cannot assign to p sub x, or I cannot assign to what is stored at that address? Well, if you focus, you'll notice that the const comes after we've placed the star in front of p sub x. So this says that we cannot change what is at that address. So having dereferenced p sub x, whatever is there is now constant. So now if we actually tried to assign to what is at address p sub x, we get a compile time error. Assignment of a read-only location. In the declaration, we said that we cannot assign to star p sub x. Here, however, is the alternative. Here it is p sub x that is declared const. So the const comes immediately before the p sub x. What this says is that the local variable p sub x is what is constant. So we can initialize p sub x with the value of the address of x, but now if we try to assign p sub x the address of y, we get again a compile time error. Assignment of a read-only variable p sub x. I tried to assign to something that was declared const, and in this case it is the local variable p sub x that is being declared const. Here I have now declared not only is the local variable p sub x const, but what it is pointing to is also declared to be const. So now I can neither change the value of p sub x, nor can I change what it is pointing to. So now if I was to try to compile this, I actually get two compile time errors. The first tells me I'm attempting to assign to p sub x, which is not allowed because p sub x was declared const. And also, I'm not allowed to assign to the location stored there. So I cannot assign to the location of p sub x. So both of those are errors. Basically, read these declarations as what is at the address p sub x is constant. The second says that the pointer or local variable p sub x is constant. And finally, both the pointer p sub x and whatever is at that address are both constant. Now, this declaring of pointers to be constant is absolutely necessary if you are trying to initialize or assign to a pointer the address of another variable that is declared constant. So here, n is declared to be const. Now, wouldn't it be sneaky if I could just assign to p sub n the address of n and then try to change what is at that address? That would be very sneaky indeed. And you'd think that during the assignment that the compiler might say, oh wait, you can't do this. But imagine how painful that would be for the compiler to keep track of, oh, this is now storing the address of something that's constant. I can't write to it. This is now storing the address of something that is not constant. I can write to it. The compiler doesn't do that. Instead, the compiler does not allow you to assign the address of a constant to a pointer that is not also declared constant. So we get an error. Instead, if you wanted to store the address of a constant to a local variable, that local variable itself must be declared to have a value that is constant. So this will now work. P sub n is declared to be a pointer, and what it is pointing at is constant. This works, so we can neither assign to n, nor can we assign to what is at the address of p sub n. We can, however, still access what is there. Now you may be wondering, why is C++ being so combative? Why does it not let you do this? Well, it's assuming you are doing something that it's trying to protect you. You've already declared n to be const. There must be a good reason for n being constant. If it is not supposed to be constant, then don't declare it to be constant. So basically, this is the compiler's way of making sure you do not accidentally shoot yourself in the foot. It's trusting that you want the local variable n to be a true constant, and it's preventing you from accidentally assigning its address to something that may subsequently be allowed to change what is at that value. So it's actually a feature. So, following this lesson, you now understand how to use const with pointers. You can protect both the local variable that is the pointer, and you can protect what it is addressing.